right now. As you watch this, something built by human hands is falling through darkness, 25 billion kilometers from Earth. It is not slowing down. There is nothing out there to slow it down. It has been falling for 47 years. It will fall for billions more. Long after every city on this planet has turned to dust. Long after the sun has expanded and swallowed the inner solar system. Long after every trace of our civilization has been erased from the universe. It will still be out there, still moving, still carrying what we put inside it. Its name is Voyager 1, and it is the farthest thing humanity has ever made. In the summer of 1977, NASA had a window, a rare, extraordinary alignment of the outer planets, Jupiter, Saturn, Uranus, Neptune, that occurs once every 176 years. The geometry of the solar system had arranged itself into a configuration that would allow a single spacecraft, using the gravitational pull of each planet in sequence, to visit all 4 outer worlds. They called it the Grand Tour, and they had one chance to take it.
Status on the trajectory update?
Deviation is minimal, holding steady.
Copy that. Proceed with the next sequence.
On August 20th, 1977, Voyager 2 launched. On September 5th, 1977, 16 days later, Voyager 1 followed. Despite the numbering, Voyager 1 was on a faster trajectory. It would overtake its twin within months and never look back. What they carried with them was not just instruments and cameras. Attached to the body of each spacecraft was a 12-inch gold-plated copper disc, a phonograph record designed to survive 1 billion years in the vacuum of space. They called it the Golden Record. The contents of that record were selected by a committee chaired by Carl Sagan of Cornell University. They had 6 weeks, a budget of $1,500, and the task of representing an entire civilization to whatever might find it. They chose 116 images, mathematical and physical quantities, the structure of DNA, the anatomy of a human being, a nursing mother, children at play, the Great Wall of China seen from above, a sunset over the ocean. They chose sounds, the wind, thunder, surf breaking on a shore, the songs of birds, the sound of a kiss, a human heartbeat, footsteps, laughter, Carl Sagan's own laughter, encoded into the grooves of a disc, now traveling through interstellar space. They chose greetings, spoken in 55 languages, beginning with Akkadian, spoken in ancient Sumer 6,000 years ago. They included a greeting from the 6-year-old son of Carl Sagan himself, a child's voice, compressed into a few seconds, addressed to whoever might one day listen, across the void. They chose music, Bach, Beethoven, Mozart, a Blind Willie Johnson blues, recorded in 1927, Chuck Berry's Johnny B. Good, an Australian Aboriginal song, a Pygmy initiation chant, 90 minutes of the most diverse music ever assembled in one place, and encoded into the record, alongside the music and the images and the greetings. They placed something else, entirely, the brainwaves of a woman named Anne Druyan. She had just fallen in love with Carl Sagan. 2 days after the most transformative phone call of her life, she entered a laboratory, was connected to medical equipment, and spent an hour meditating, thinking about the history of the Earth, about the problems of our time, about love. Her neural activity was compressed and encoded into the record. An hour of human thought and feeling, reduced to a minute of data, pressed into gold. It is out there now, in interstellar space, the thoughts of a woman in love, traveling at 61,000 kilometers per hour, addressed to no one in particular, and everyone who will ever exist. Voyager 1 reached Jupiter in March 1979. What it found there changed everything we thought we knew about the outer solar system. Io, Jupiter's innermost large moon, was not the dead frozen rock scientists expected. It was volcanically active, erupting continuously, its surface repaved by lava flows on a timescale of months. Active volcanism on another world, seen for the first time in human history. Europa showed something even more provocative. Beneath its surface of ice, the gravitational flexing caused by Jupiter's immense gravity appeared to be generating heat. Enough heat, perhaps, for a liquid ocean. We filed that thought away. We would come back to it. Then Voyager 1 left the planetary plane entirely. Its trajectory after Saturn was aimed upward, out of the ecliptic, away from the remaining planets. There would be no Uranus, no Neptune. Those would be left to Voyager 2, following a different path through the same darkness. Voyager 1 was heading out. On February 14th, 1990, at the suggestion of Carl Sagan, Voyager 1 turned its camera backward for the last time. It was 6 billion kilometers from Earth. The cameras had been scheduled for deactivation. They consumed power needed for other instruments, but Sagan had argued for one final image before they went dark. What the camera captured was a single pale point of light, barely 1/12 of a pixel in size, suspended in a beam of scattered sunlight. That was Earth. Every person who ever lived, every war ever fought, every civilization ever built, every child ever born, every piece of music ever composed, the totality of human experience, visible from Voyager's distance, as a pale blue dot. Sagan wrote that our planet is a lonely speck in the great enveloping cosmic dark, that there is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. The cameras shut off after that. They have never been turned on again. They never will be. For decades, Voyager 1 crossed through the outer regions of our solar system, toward the boundary scientists called the heliopause, the point where the solar wind, the constant stream of charged particles from our sun, finally loses the battle against the interstellar medium, the thin sea of matter that fills the space between stars. In August 2012, the instruments aboard Voyager 1 detected something change. The density of particles shifted, the magnetic field orientation altered, the cosmic ray count increased sharply. Voyager 1 had crossed the heliopause. It had left the solar system. It had entered interstellar space. For the first time in 4.6 billion years of this solar system's existence, something originating here had crossed that boundary under its own mission. Not a natural object thrown out by gravitational perturbation. A deliberate, designed, intentional object. The signal confirming this crossing took 17 hours to reach Earth. We built something that left the solar system, and it told us when it happened. Right now, in 2026, Voyager 1 is losing power. Its 3 radioisotope thermoelectric generators, nuclear batteries, fueled by the radioactive decay of plutonium-238, lose approximately 4 watts of output every year. At launch, they generated 470 watts. Nearly 50 years later, they generate roughly a third of that. The thermocouples converting heat to electricity are degrading. The spacecraft is running out of time. NASA has responded the only way it can, turning things off, one instrument at a time. The cameras went first in 1990. The cosmic ray detector, deactivated in early 2025. Others have followed. Each deactivation is a small, quiet death, a capability that existed, then didn't. What remains are a magnetometer and a plasma wave subsystem, instruments measuring the local magnetic field, instruments listening to the electron density of interstellar space, the most minimal possible science. The spacecraft at the end of its life, doing what it can with what it has left. The signal from Voyager 1 currently takes 23 hours and 32 minutes to reach Earth. Every command sent to it requires 2 days just to be acknowledged. And the engineers at JPL will send those commands anyway. Carefully, patiently, because it is still out there, because it is still talking. When Voyager 1 finally goes silent, when the last watt of power drains from the last thermocouple, when the transmitter falls quiet and the antenna drifts imperceptibly away from the direction of Earth, the spacecraft will not stop. It will continue at 61,000 kilometers per hour in 40,272 years. It will pass within 1.7 light years of a star in the constellation Ursa Minor. Not close enough to enter that star's system, just a passing encounter in the dark. Then it will keep going. When we use the word void, we mean something specific. Interstellar space is not empty, in the way a room is empty. There are approximately 1 atom per cubic centimeter, mostly hydrogen and helium, left over from the Big Bang. There are cosmic rays, faint magnetic fields. But the distances involved reduce all of this to something that functions experientially as nothing. There is no destination. There was never meant to be a destination. Voyager was not sent to arrive anywhere. It was sent to cross boundaries, the orbit of Jupiter, the orbit of Saturn, the heliopause, the record for distance, the threshold between the known and the unknown. It has crossed every one of them. Now it crosses the void. Carl Sagan wrote about Voyager that it was a gift across the cosmic ocean, from one island of civilization to another. He wrote that not because he believed anyone would find it. He believed the probability was vanishingly small. He wrote it because he thought the attempt itself said something important about who we are. We are the species that builds things and throws them into the dark with messages inside. We do this not because it is practical. We do this because something in us refuses to accept that we are alone, without at least trying to prove otherwise. We are a species that has existed for approximately 300,000 years on a planet orbiting an unremarkable star in the outer arm of an average spiral galaxy. In 1977, for 6 weeks, with $1,500 and the best minds we could find, we tried to say something true about ourselves. We said, we have oceans, we have music, we have children, we have laughter, we have the ability to fall in love. We know something about mathematics and DNA. We are trying to survive our time so that we may live into yours. That record is out there now, moving through the dark between stars, carrying every one of those things, moving away from us at a speed that adds 523 million kilometers to its journey every year. It will not stop. Neither, perhaps, should we?